This is the video for accelerated geometry on section 19-3 on piecewise functions. Key vocabulary in this lesson is piecewise function and step function. The essential question is, how do you write and graph piecewise functions? To begin, the definition of a piecewise function is a function that is a combination of one or more functions. The rule for a piecewise function is different for different parts or pieces of a domain. For example, movie ticket prices are often different for different age groups. So the function for the movie ticket prices would be assigned to different values, which are the ticket price, in each domain interval, which is each age group. Also remember that if we're using interval notation, that the square brackets indicate that the point is included, and the parentheses indicate that it is not. A piecewise function that is constant for each interval of its domain, such as a ticket price function, is called a step function. You can describe piecewise functions with a function rule. So for example, this is what a piecewise function looks like. So this first part is your rule. So this first part here is our rule for the function. And this part over here is our domain. Okay, so this is what we call a special type of piecewise function, which is a step function, because if you notice, every rule here is just a constant. So what this is telling me is that at negative, for the x equals -2, I'm at 5. And because there's no equal sign right here, tells me it's going to be an open hole. At 4, I'm still at 5. But because there is an equal sign here, I'm going to have a closed hole. So that gives me -2, 5, with an open hole, and 4, 5, with a closed hole. And then we're going to connect them. The next graph, we have 4, -2, and there's no equal sign, so that's going to be open. And then we have 6, -2, and again, there's no equal sign, so that's going to be open. So 4, -2, and 6, -2, and connect them. The last one, we have the point 6, 7, and it's closed because it's equal. And we have the point 9, 7, and it's also closed because it's equal. And this one should be right here. So that would be our graph of this special piecewise, which we call a step function. And if you notice with a step function, each piece of graph is just a horizontal line between 2 points. Next, we're going to evaluate piecewise functions. So in this case, the directions say to evaluate each for x equals -1 and x equals 4. So first things first, for the x equals -1, you want to decide which part of the domain -1 fits. So is -1 less than or equal to 2? Yes. So since -1 is less than or equal to 2, that means I'm going to use the function of 2x plus 1. And I'm going to plug in -1. So that gives me 2 times -1 plus 1, which would give me -1 plus 1. I'm sorry, -2 plus 1, which is -1. So I can say that when x equals -1, h of x equals -1. Then for x equals 4, 4 is not less than or equal to 2, so I can't use that function. 4 is greater than 2, so I'm going to plug it into x squared minus 4. So that's going to be 4 squared minus 4, which is going to be 16 minus 4, which is 12. So then when x equals 4, h of x equals 12. Let's try another one. Negative 1 is less than or equal to negative 1, so that's going to be plugged into the 2x. So that's going to give me 2 to the negative 1, which is just 1/2. So when x equals negative 1, g of x equals 1/2. For 4, 4 is greater than negative 1, so that's going to go in the 5x. So 5 times 4 is 20. So when x equals 4, g of x equals 20. One more. Negative 1 is not less than negative 3, so we're not going to use that one. Is negative 1 between negative 3 and 6? Yes. So this is a step function because these are just constant. So when x equals negative 1, f of x is going to equal that constant, which is 15. For the 4, when x equals 4, 4 is not less than negative 3. 4 is between negative 3 and 6. So again, we're using this middle one again. So we'd still have that f of x equals 15. Absolute value functions can be written as piecewise functions as well. So let's take a graph that we have been studying, which is the absolute value, and I'm going to write this absolute value function as a piecewise function. So the first thing I'm going to do is find my vertex. So in this case, the vertex is at -5, -4. Okay, I know that my piecewise function is going to take on the form of f of x equals a bracket. Then there's going to be a rule and the word if, and then our domain restriction. Well, in this case, our domain restriction, you're going to have two sides here. You're going to have when the x is greater than the x-coordinate of the vertex and when it's less than the x-coordinate of the vertex. And I always do the right side of the graph first. That's just a preference here. So if I start with the right side of the graph first, then this is always going to be x is greater than the x-coordinate of the vertex, which is -5. And that means the other one has to be less than the x-coordinate of the vertex. And one of these gets the equal sign. It doesn't matter which one. So then the next thing is to write our rule. If you notice, each piece of the absolute value is a line, and the general equation for a line is y equals mx plus b. So my first step is to find the slope, and we can find the slope by using the vertex and another point on the line. So if you look at the right-hand side here, it looks like it goes through this point right here, -3, 0. So I'm going to use the point -5, -4, and -3, 0. And you can either use the slope formula to do this, or you can actually use your rise over run, however you want to do it. So we would have 0 minus -4 over -3 minus -5. So that's going to give me 4 over 2, which is just 2. So the slope of the first one is 2, which makes it 2x. Automatically, that means the left side has to be the opposite slope. So if this is a +2, the other one has to be a -2. And this is because this is an absolute value function. Okay, the next step is to find our y-intercepts. It looks like it's easy to find the right-hand side because I can tell that it crosses at 6. So then this is just 2x plus 6. However, for the left-hand side, it's not as easy. However, you can do one of two things. You can use your slope and go down until you touch the y-axis. So in this case, I would continue to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And it's going to be way down here, which looks like it would probably be about -14. However, if we're unsure about that, we can take our equation of a line, take your vertex, that's going to be an x and a y coordinate, and you know your slope. In this case, the slope is -2. So my y is -4 equals my slope times my x, which is negative 5, plus b. So I have negative 4 equals 10 plus b. Subtract the 10, and you get that the b is indeed negative 14. So that means this piece here has to be minus 14. And you're done. Let's try another one. So first thing I'm going to do is identify my vertex, which in this case, it's at negative 2, 1. I know my equation is going to take on the form of f of x equals a bracket, something if I do the right-hand side first, and that's going to be x is greater than the x-coordinate of the vertex is negative 2, and then x is less than the x-coordinate of the vertex, which is negative 2. And one of these gets the equal sign. It doesn't matter which. So then the next step is to find the slope. So using this point and finding another point on there, which looks like it's right here. So I'm going to use the vertex, and it looks like it's at 1, negative 2. So negative 2 minus 1 over 1 minus negative 2. It's going to be negative 3 over 1. So my slope on the right-hand side is negative 3. So if this one's negative 3x, then the other one has to be a positive 3x. Then I can see where it crosses the y-axis here. So that's going to be at negative 5. So this first one would be negative 3x minus 5. The other one, I can either use my slope. Since it's positive 3, I can go up 1, 2, 3 over 1. 1, 2, 3 over 1, and it crosses at 7. Or you can use that formula, just to show you it works, of y equals mx plus b. The x and the y come from the vertex, which is at negative 2, 1. And my slope on this one was positive 3. So 1 equals equals 3 times negative 2 plus b. So you have 1 equals negative 6 plus b. So add the 6 back over, and you do indeed get that the b is 7. So that number would be 7. Now let's try writing a piecewise for a little bit harder of a graph. So first thing we're going to do, we know we have f of x equals. Now there's 3 pieces here, so I know I'm going to have 3 functions with 3 different domain things here. Let's do the horizontal line first. And since it's a horizontal line, I know it has to be y equals a number. In this case, it's negative 1, 2, 3. If the x values here look to be at negative 3 to 1. So that's going to be negative 3 is less than x is less than 1. And then go back and look at your points. Is there any one that is shaded? In this case, this one is, which tells me it has to be equal, and the x value there is 1. So the 1's going to have the equal sign. So we're done with this part. That's what we did in purple. The next graph, do the easy part first, which is our domain. It looks like it starts at 1, 2, 3, 4, 5. So it's going to go from 1 to 5. And the closed hole is on 5. So that's going to be the equal sign. Next thing we're do is find our slope. So pick another point on here. It looks like it goes through right here. And so I'm going to go up 1, 2 over 1. So that gives me a slope of 2. And then figure out where it crosses the y-axis, either by using the formula that we just went over, or just going backwards. So if it's a slope of 2, that means I can also go down 2, 1, 2, and to the right 1. To the left 1, which means that this point would be on that line if it extended past the x of 1. So this would be at 0. So you can write the imaginary 0 here if you want, but it's not needed. So I would probably just leave this as 2x. And then we have the third graph here, which looks like it starts at 5, 6, 7, 8, 9, and ends at 9. And the 9 has the closed hole, so that's going to be equal. So again, I'm going to find the slope of this line, and it looks like we're just going up 1 and to the right 1, so it just has a slope of positive 1. And then I'm going to use that backwards towards the y-axis to figure out where it would cross. So I'd go down 1 to the left 1, 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 which means it would cross at 1, 2, 3, -4. And then we're done. So this piecewise function matches this graph. So we've gone from writing the equations from the graph. Now we want to graph them given the equations. So what you're going to do is look at your starting point right here, which tells me that I have the endpoint of 0. Well, x is 0. So I'm going to plug that into my equation. So if I have 1/4 of 0 plus 3, that's going to give me the ordered pair of 0, 3. And it's not equal to, so it's going to be an open hole. Next, so that I know which direction it goes, since there's no boundary here, there's not 2 points that it cuts it off to a beginning or an end. It looks like it just continues to the left. So I'm just going to pick a number less than 0, say -4. And I did -4 because I knew that it was divisible by 4. So when I plug in -4 here, 1/4 of -4 is -1, and -1 plus 3 is 2. So I know it has to go through that point. So when I graph this, 0, 3, I have an open hole, but then I also know which direction it has to go because I have to go through that point right there, which tells me my graph looks like that. Then if I graph the second piece, I'm going to plug in 0 again. So -2 times 0 plus 3 is going to give me 3. But now there's an equal sign, so it's going to be closed. And it's going to the right side because greater than. So I'm going to pick a number greater than 0, say 1. So -2 times 1 is -2 plus 3 would give me 1. So that tells me it has to go through the ordered pair 1, 1. So I'm going to have a closed hole here now that's in green. And I know it has to go through this point. And so that would be my graph. Let's try another one. So I can plug in 0. So 0 squared minus 3 is going to be -3. And it's going to be open. And then less than, let's do -1. -1 squared is 1. 1 minus 3 is -2. So that tells me it also has to go through the point of -1, 2. So 0, -3, and it's open. It has to go through -1. Should be -1, -2. Sorry about that. So it's going to have to go through this. And you should recognize that this is a parabola because it's an x squared. So we're going to do our best to make this look like a parabola and not just a straight line. For our next one, I'm going to move it off to the side here to have a little bit more room. Starts at 0, so if I plug in 0, that's going to give me the point 0, 3. And it's equal to, so it's going to be closed. Then I also have a second point, so if I plug in a 4, 1/2 of 4 minus 3 is going to give me -1. But it's not equal to there, so it's going to be open. So I'm going to put a solid here, and then I'm going to go to 4, -1, and it's going to be open. And then I'm going to connect those 2 points. And then lastly, if we plug in 4, 4 minus 4 is 0, squared is 0, minus 1 gives me 0, -1. I'm sorry, 4, -1. I plugged in 4 and got out -1. And this is going to be closed. Greater than means a number bigger, so I'm going to plug in maybe 5. So if I plug in 5, I'm going to get out 0. So it has to go through that point. So now this is closed. And then I know it has to go through that. And again, this is an x squared, so it's going to take on the shape of a parabola as best as you can right here. And you're finished. One more. This is a step function, so this is probably the easiest of all piecewise functions. So if I plug in -1, I'm still going to get out 4, and it's going to be a closed hole here because it's equal. And less than here means that everything to the left. So at -1, 4, I'm going to have a closed hole, and then everything to the left on 4 would be part of that graph. This one's going to give me -1, -2, but it's not equal to, so it's going to be open. And greater than means everything to the right. So at -1, -2, we have an open hole, and then everything to the right. And we are finished.